Okay, we're going to be talking in this video about equations with special cases. Now, one of these equations will have one solution, one of them will have no solutions, and one of them will be all real numbers or infinitely many solutions. So let's go ahead and start with this first one so that you can see what each one looks like when it's one solution, no solution, or infinitely many. So first thing we need to do on this equation is we need to distribute. Okay, if you can distribute, that's what you want to do first. So we have 13 plus 2 times x, which is 2x, 2 times negative 6, which is negative 12, equals 4x minus 7. Okay. Now, we want to combine any like terms that we can combine. So we have 13 and negative 12. 13 minus 12 is 1, so we're just left with 2x plus 1 on this left side and 4x minus 7 on the right side. Now we want to gather all the variables to one side. So I'm going to subtract 2x, and what I do to one side I have to do to the other. The reason why I'm going to do that is it's going to keep my variables positive. So 2x minus 2x is 0. I'm left with just 1 on that side. And here is 4 minus 2, so that's going to be 2x minus 7. Now we want to go ahead and add 7 so we can get that 2x all by itself. What I do to one side, I'm going to do to the other. So I'm left with 8 equals 2x. My last thing, my inverse operation of multiplication, because this is 2 times the variable x, we're going to divide by 2. What I do to one side, I do to the other. So this is just 1, so we're left with 1x equals 4. 8 divided by 2 is 4. So our answer is x equals 4, and that means that this is one solution. Okay, that makes this one solution. So let's move on to our second one. It's 4x plus 12 minus 8 equals 2x plus 3 plus 2x. First thing we want to do, there's nothing to distribute, so let's go ahead and combine like terms. We have like terms here, 12, negative 8, and 2x and 2x. So we're left with 4x, and then 12 minus 8 is 4, so 4x minus 4 equals, we have 2x plus 2x, which is 4x plus 3. Okay, bring that 3 down there. So let's go ahead and collect the variables to each side. So they're both 4x, so let's just subtract 4x from this side. What I do to one side, I've got to do to the other. So this is 0. What I do to one side, I do to the other. So 4x minus 4x, oh, this is 0 as well. So we're left with negative 4 equals 3. Does negative 4 equal 3? Is negative 4 the same thing as positive 3? No, it is not. So when you're left with something that looks like this, the end of your equation, after you've collected the variables to each side, you know that it is no solution. Okay? There's no solution. These do not work. Negative 4 and 3 do not equal each other. That is how we know that this problem is no solution. Now, last problem. There's nothing to distribute here. There's no like terms to combine. So let's just go ahead and collect the variables to each side. Okay, so we'll start doing that by, we have negative 5x, so we've got to add 5x. What we do to one side, we've got to do to the other. So negative 5x plus 5x is 0. Negative 5x plus 5x is 0. So I'm left with 13 on the left side, and I'm also left with 13 on the right side. So this says 13 equals 13. Now, this is a true statement. 13 is the same as 13. If you said you have $13 and somebody else said they had $13, well, you guys have the same amount of money, right? If I said you have an equal amount of money, that would be a true statement. So when you're left with a true statement here, like 13 equals 13, or 4 equals 4, or 0 equals 0, you know that it's going to be infinitely many solutions. Infinitely many solutions. Okay, that means any number could be plugged in for x and it would solve the equation. Okay, all real numbers. So that is how you solve equations with special cases. That is what equation with one solution looks like, an equation with no solutions looks like, and an equation with infinitely many solutions looks like.